Welcome everyone. Today I'll discuss about an important topic of application of calculus. The topic is increasing and decreasing function. So before we start, we recapitulate the basic concept. Increasing and decreasing function. So, graphical idea. So we know y equals to x is a straight line. So look, as x increases, look, this is fx, that is y increases. So x increases implies y increases. So then the function is called increasing function. Now in general, suppose this is y equals to fx. We do not know the nature of fx. It may be of any curve. So this is x equals to a, and this one x equals to a plus h. So this is f a plus h, and this is f a. So a function fx is said to be increasing at x equals to a if fa plus h greater than equals to fa. If fa plus h greater than equals to fa, where h greater than 0, very small, very small. So this is definition. Now, if we take tangent at x equals to a, this is pt, then tangent makes an angle psi with positive x-axis. So, at x equals to a, tangent makes acute angle with x-axis. Therefore, dy dx equals to tan psi for acute angle greater than 0. So this is condition of increasing function. So strictly increasing or monotonic increasing. So if a plus h greater than fa. So in this case also, what is the condition? Dy dx greater than 0. So unless otherwise stated, for increasing, we consider it as monotonic increasing or strictly increasing. So look, suppose a function, so this is suppose a function. Now here for this part, this is increasing function, this is also increasing function, and this is constant. Fx equals to constant. It is also increasing function, increasing. So in this, for this part, dy dx equals to 0. So for increasing function, that is why we take condition for increasing function dy dx greater than equals to 0. And for monotonic increasing or strictly increasing, dy dx greater than 0. So look, for strictly increasing function, figure, so this type, suppose y equals to x. So x1 and this is x2. So x1 and x2. So fx1 not equals to fx2. That is, it is 1-1 function or mapping. So if a function is strictly increasing, then it is 1-1 function. You recall this property. So this is for increasing. Now decreasing. So take a practical example, y equals to minus x. So this is, so as x increases, look, y decreases. Y, this is decreases because this is negative y. So y equals to minus x is decreasing function. Now, if we get a figure like this one, y equals to fx, this is x equals to a, this is a plus h, so f a plus h, and this is fa. So here f a plus h less than fa. So a function fx, if you go right, then ordinate decreases. A function fx is said to be decreasing at x equals to a if fa plus h less than fa. So this is decreasing function. This is fa plus h. This one is fa plus h and this is fa. So fa plus h is less than this, decreasing. Where e is greater than 0, very, very small. And if we draw tangent, then tangent makes obtuse angle, then dy dx equals to tan psi, so less than 0. So this is condition for decreasing function. We solve problems using condition, not using this definition, dy dx less than 0. Now, if we get a figure this type, look, this is strictly monotonic decreasing, and here fx equals to constant. So for this part, dy dx less than 0. For this part also, dy dx less than 0. But for this part, dy dx equals to 0. Tangent is parallel to x-axis. For decreasing function, so this is our working rule, dy dx less than 0. So for strictly decreasing, dy dx less than 0. And if it is not given, it is strictly, then we suppose that for decreasing, if it is only given, we take dy dx less than 0. Now, for decreasing function also, look, this is x1, this is x2. So fx1 not equals to fx2. So function is, mapping is 1, 1. So this is useful result. So if a function is increasing or decreasing, then the function is 1, 1. Now for increasing function, dy dx greater than equals to 0 and dy dx less than equals to 0. So this is our working tools of these topics, increasing and decreasing function. Now we solve some important problem of this chapter. 36x plus 36 for in decreasing, strictly decreasing, f dash x less than 0. So 6x square minus 30x plus 36 less than 0. So x square minus 5x plus 6 less than 0. So x minus 3, x minus 2 less than 0. Now look, it is inequation, problem of inequation. If it is less than 0, we know value lies inside the interval. Look, for greater than 3, f dash x, so 6 into x minus 3, x minus 2. So for greater than 3, f dash x, greater than 3, 4, this is positive, this is positive. So f dash x is positive. For less than 2, suppose this is 1, negative, negative, positive. So here f dash x is also positive. So in between 2 and 3, so suppose 2.5, this is positive, this is negative. So f dash x equals to negative. So we are getting negative in equation. So function is decreasing in 2, 3. So if it is less than 0, so for competitive examination, so value lies inside. So right answer this. Now function is increasing in, look, less than 2. So minus infinity, 2, union 3, infinity. So it is decreasing in 2, 3. So very simple and important problem for board. Now we consider problem number 2 and 4. They are exactly same. Fx equals to 0. Then fx equals to 0 has 13 roots, 1 positive, 1 negative, 1 real root, 2 positive, 1 negative root. Similarly, the fourth one. So fx equals to this. So what is f dash x? 13x square, 11x to the power 10, 9x to the power 8, 7x to the power 6, 3x square plus 1. Now look at the form of fx. Look, only odd powers are given. Here also odd powers are given. So if you differentiate odd positive power, we get even positive power. So look, this is all powers of x are even. So they must be positive. So here f dash x greater than 0. So fx is increasing. So here fx is increasing function. Now what is f0? f0 equals to 19. f0 equals to 19. Now what is f infinity? f infinity is infinity. F of minus infinity, so odd power. So all are odd power. So this is minus infinity. So if you look the nature of the curve, nature. So what is f0? f0 is 19. F minus infinity is minus infinity. And f plus infinity is infinity. So f plus infinity, so this is 19, you get increasing nature. So this will be figure like that, like this. So this is 0, 19. It is increasing nature because f dash x greater than 0. F minus infinity is infinity. So look, from nature of the curve, since it is increasing, it cuts x-axis at only 1 point. At only 1 point. Because it is increasing, it cuts x-axis at only 1 point. So only one real root. Only one real root. So fx equals to 0 has 13 roots. This is wrong. 1 positive, 1 negative. This is also not more than 1 real root. Not more than 1 real root. Here only 1 real root. It will be answer because f infinity is minus infinity here. So it must cut x-axis at a point. So C will be possible answer. So problem number 4, exactly same, look, odd powers. So A will be possible answer. Now we consider two similar like problem. The value of k so that fx is decreasing. So fx equals to sin x minus cos x minus kx plus 5. So f dash x cos x plus sin x minus k. So for decreasing function, so f dash x less than equals to 0. So cos x plus sin x minus k less than equals to 0. So cos x plus sin x less than equals to k. So divide by 1 by root 2 to get in terms of sine or in terms of cos. So this is cos x cos pi by 4, sin x sin pi by 4 lesser than equals to k by root 2. So sin x plus pi by 4 lesser than equals to k by root 2. K by root 2. Now we know so we are getting this, we know sin x plus pi by 4 lesser than equals to 1. Sin x plus pi by 4 lesser than equals to 1. So we are getting root 2, look, root 2 sin x plus pi by 4 minus k less than equals to 0. So this is always less than equals to 1. So to make it negative, so this is less than root 2. So this is less than equal to root 2. So to make it negative, So k must be greater than root 2. K must be greater than root 2. So you look the answer. Here only greater than 2 is given, not greater than equals to 2. Here k less than. So in this case, if it is not given decreasing function, we use this one, f dash x less than. So less than, we use less than. So less than. So now this less than 0. Now this is always less than equals to root 2. Now to make this one negative, so k must be greater than root 2. So if it is greater than root 2, then total thing is negative. So k will be greater than root 2. Listen again, this is f dash x less than 0. Now our main aim will be to express it in terms of single sign or cos. So we know you have to divide throughout by root 2. So this is sin x plus pi by 4 lesser than this. So root 2 sin x this. So to make it negative, k must be greater than 2. So C is possible answer. C is our possible answer. Now problem number 7. Problem number 7. So this is exactly same problem and it is simple also. So f dash x equals to cos x minus k for decreasing function, decreasing f dash x. This is 1 marks problem of Wbjee, f dash x less than 0. So cos x minus k less than 0. So maximum value of cos x is 1. So if k equals to 1, this is 0. So if k is greater than 1, so it is negative. So what is the value of k? K greater than 1. K greater than 1. For strictly increasing, k greater than 1. And for increasing function, for strictly decreasing function, f dash x less than 0. So cos x, this is 1, maximum is 1. So k must be, to make it negative, k must be greater than 1. So k greater than 1 for decreasing, strictly decreasing. And for decreasing only, k greater than equals to 1. So look, if it is given for decreasing only, then if greater than and greater than equal to, both options are given, then you have to look the language. Since it is greater than also given, so for decreasing we use lesser than equals to 0. So this is lesser than equals to 0. So k greater than equals to 1. So for k greater than equals to 1. So B will be possible answer if it is decreasing. For strictly decreasing, k will be greater than 1. So you should see the restriction. So it is decreases only. That is why option B. Now to similar like problem, fx equals to sin to the power 4x plus cos to the power 4x. Then fx is increasing in which interval? Fx equals to sin x minus cos x. The interval in which it is decreasing. So problem number 5. F dash x equals to 4 sin cube x into cos x. 4 cos cube x into minus sin x. So 4 sin x cos x common. So sin square x minus cos square x. So 2 into sin 2x and this is minus cos 2x. So minus cos 4x. Minus cos 4x. Now for increasing f dash x greater than 0. So minus cos 4x greater than 0. So cos 4x, sorry, this is sin 4x. Sorry, sin 4x. Sin 4x. So sin 4x less than 0. So sin is negative in third and fourth quadrant. So therefore pi less than 4x less than 2 pi. So pi by 4 less than x less than pi by 2. So it is increasing when sin 4x less than 0. So sin x is negative in pi to 2 pi. So here here argument is 4x. So in terms of x, we get option number C. Now consider problem number 13. So f(x), so f dash x equals to cos x plus sin x. So we have already done this problem. So this is sin x plus pi by 4 and this will be root 2. Root 2 balance 1 by root 2 cos x, 1 by root 2 sin x. For decreasing f dash x less than 0. So sin x plus pi by 4 less than 0. So pi less than x plus pi by 6 less than 2 pi. So pi minus pi by 6 less than x, 2 pi minus pi by 6. So 5 pi by 6 less than x less than 11 pi by 6. So decreasing in the interval, yes. So 5 pi by 6 less than x less than 11 pi by 6. So you may take any point inside the interval and put values of this and verify whether it is less than 0 or not. So this one is general method. So exactly same problem. Now consider problem number 7. The function f(x) is strictly increasing in which of the following interval? Now f(x) is given. So what is f dash x? 3x square plus 12x plus 9 plus 2k. 3x square, 12x, 9 plus 2k. So for strictly increasing, it is given increasing f dash x greater than 0. So 3x square plus 12x plus 9 plus 2k greater than 0. This is quadratic expression. We know, try to recall this quadratic expression f(x). It is positive. We have already discussed it. It is positive when theory is a greater than 0 and d less than 0. So this is parabolic cut like this. It does not cut x-axis. So here a is obviously positive. Therefore d of the corresponding equation less than 0. Discriminant less than 0. Discriminant of the corresponding equation. What is d? 144 minus 4 into 3, 9 plus 2k less than 0. So divide by 12. So 12 minus 9 plus 2k less than 0. So 3 minus 2k less than 0. So 2k minus 3 greater than 0. So k greater than 3 by 2. So option A. So very simple. Look, most important problem this one, f dash x. For increasing we are getting this condition. Now this quadratic expression is positive when we know the theorem. This quadratic expression is positive when a greater than 0, coefficient of x square greater than 0 and d less than 0. Here it is 3, obviously greater than 0. So we consider discriminant and make it less than 0. Next, problem number 15. So fx equals to this is increasing in. So f dash x 1 by 1 plus sin x plus cos x whole square and cos x minus sin x. So derivative of tan inverse x 1 plus x square this. Now denominator is obviously positive. So for increasing f dash x greater than 0. So this is obviously positive. So cos x minus sin x. So this is greater than 0. So in 0 to pi by 4, cos x minus sin x is positive. So in 0 to pi by 4. So look at the graph. So this is minus pi and this is plus pi. Minus pi by 2 to plus pi by 2. Interval is given. This is sine curve and cos curve 0, this is 1, pi by 2, this is 0. This is pi by 2, this is minus pi by 2, y equals to cos x and y equals to sin x 0 to pi by 2, this is 1. So graph is this is minus pi. But here interval is minus pi by 2 to plus pi by 2. Now cos x, this cos look lies above sine curve for this part 0 to pi by 4. This is obviously 0 to pi by 4. Here also this curve is above from minus pi by 2 to 0. This is cos curve and this is sine curve. So this is above. So minus pi by 2 to pi by 4. This is pi by 4. Cos curve is above sine curve. So from graph, so answer will be, if it is minus pi by 2 to plus pi by 2, answer will be, you look, minus pi by 2, C will be our answer. Minus pi by 2 to plus pi by 4. Minus pi by 2 to plus pi by 4. Cos x greater than sin x. So cos x minus sin x greater than 0. So this is also most important problem. Now consider problem number 8. fx equals to this is increasing for all x. If, what is restriction on f? So for increasing f dash x, you find f dash x, sin x plus cos x whole square, sin x plus cos x unchanged, a cos x minus 2 sin x minus a sin x plus 2 cos x unchanged. So this is cos x minus sin x. So this is obviously positive. Denominator is obviously positive. So a cos x sin x, a cos x sin x plus a cos square x, 2 sin square x, 2 sin x cos x. So fourth term minus a sin x cos x, 2 cos square x, a sin x cos x minus 2 sin x cos x. So a sin x cos x, a sin x cos x cancel. Minus 2 sin x cos x, this is plus 2 sin x cos x cancel. So finally we are getting, you look, a cos square x, and this is a cos square x. So a sin square x, this is 2 sin x cos x. So a sin x cos x, 2 cos square x, a sin square x, this is a sin square x. So a cos square x plus a sin square x. So this is a sin square x plus cos square x minus 2 sin square x minus 2 cos square x. So finally we are getting a minus 2 by sin x plus cos x whole square. So look, it is positive. So to make f dash x positive, so a must be greater than 2. If a greater than 2, then f dash x is 0, greater than 0. So fx is increasing when a greater than 2. A greater than 2. So only we need simplification. So derivative and make simplification. So value of a is greater than 2. Now finally we consider problem number 11. X square equals to 0. The number of points in it for which fx equals to 0. Roots of fx. So f dash x, 2x minus x cos x plus sin x plus sin x. So sin x cancel. So x common, 2 minus cos x. So 2 minus cos x is always positive. So 2 minus cos x is always greater than 0. So if x greater than 0, then f dash x is positive and f dash x is negative if x less than 0. Now look, therefore for greater than 0, fx is increasing, and for less than 0, fx is decreasing. Now what is f0? f0 equals to, this is 0, 0, this is minus 1. f0 is minus 1. Suppose this one is minus 1. So for greater than 0, it is increasing. So we are getting roughly a figure like this. And for less than 0, it is decreasing. It is decreasing. It is decreasing. So decreasing, not like a parabola, decreasing curve, any type of decreasing curve, this. So it cuts x-axis. It cuts x-axis at 2 points, here It is decreasing in this, decreasing, it will be decreasing. So it cuts x-axis here and here at 2 points, at 2 points. So f infinity is infinity and f minus infinity also plus infinity, it is x square. So it cuts x-axis at 2 points. Therefore it has 2 roots. It has 2 roots. So we have solved some important problems of the chapter increasing and decreasing function. I will also take one more class for increasing and decreasing function. So thank you for today.